most of the time we don't necessarily know what we're looking for yet either. Being able to store that and figuring out what is useful and not is sometimes just takes a long time for us as data professionals, right? And so trying to identify like what is important, and now being able to realize people are saying, oh, we want to actually really have a whole bunch of word embeddings or documents translated into those embeddings so that we can look and search for them.
Sarah, welcome to the Data Bites podcast. How's your day going so far?
Pretty good, pretty good. I'm very glad to be here. Thank you for inviting me.
Yes, thank you for coming. I've been a big fan of your work and also your Twitter posts, or I don't know if we call it, do we call it X now? I still type in Twitter to get to it online, but the app looks like that. So I'm a big fan of what you post on that platform, particularly in regards to data engineering. I'm so excited to dive into a lot of just opportunity, the hype, and what's going on in the field of data engineering and ML platform engineering as well. So thanks for taking the time to be with us. So one of the things that really attracted me to you and was like, I need to reach out and learn more is you were talking about vector databases. So can you just start by explaining in simple terms for all of us, what is a vector database and how is this different from traditional databases?
Right. So traditional databases, think of it like Redshift or Postgres. You basically have just like a row of information, and it has columns, right? And so each column and row has some text or number or whatever. The relationship is essentially the row and columns, right? So the key difference between a vector database is that there is you're now, like, let's say, taking an image or words or sentences, right? So like, I like bananas, right? That becomes like 3 different integers. So it becomes an array and then goes into those arrays become what's called an embedding, and that is really what it stores. So you can compare row and columns to this embedding, right? So not necessarily word all the time, but that's the example I was going for. So if we take those embeddings and we put them closer together, different embeddings, the closer together they are, the similar they are. So like, let's say if I say I like bananas, that's 1, 2, 3. I like strawberries, right? The strawberries and bananas are pretty close. They're fruit, right? So it'd be like 1, 2, 4, let's say. Or if it's like I like driving or biking, that now becomes like a 10 or 11, right? And so you have different values for how close things are together. And the key there is that they will end up, the proximity between those is what is really important, right? So you can find different things that are this similar, and then so that's really what makes a vector database a vector database, is that similarity between the two. Or between the multiple embeddings that you have.
So what type of challenges then do you see the vector databases solve, which can't be handled by traditional databases? Or what's the advantage of using a technique like this?
Yeah, so vector databases solve, so typical traditional databases cannot store images like the ones that I was just talking about, or the word embeddings naturally, or it just takes up a lot of space, or that and so traditional databases can't store images. And one of the things is trying to figure out where those images are located and finding out. So like there's no, I mean, there's indices, right? And people will search based upon indices, but you can't just say like, oh, image, like 1, an image 2, there's no way you can know how close really that they are, right? And so with vector databases, like let's say if image 1 is a plant and image 2 is also a plant, like those are naturally going to be close together. They're going to be positioned together. And so being able to find that piece of data so much quicker is going to give, like if you're thinking about like Facebook, for example, you can just easily find, oh, this image is together and this image is also like very closely related. So that's a huge plus for vector databases, and that images and like translations, and there's a whole bunch of applications when it comes to databases. So that's the main key advantage to using vector data.
So, are we seeing this being driven or the adoption of it from the data science and ML communities just because of the amount of unstructured data and the amount of data that is out there? Or what do you think is driving the current hype around vector databases in both the data science and ML community?
So there's two, right? So there's obviously large language models that we're all talking about, right? Being able to assembly translate that amount of data. Like people are really interested in trying to figure out like, hey, like, there's so many applications for that. So that's definitely a huge plus for vector databases, right? But even then, like figuring out what we can do with images, right? So you were mentioning just now, like the large amount of data, unstructured data. Most of the time, we don't necessarily know what we're looking for yet either. Being able to store that and figuring out what is useful and not is sometimes just takes a long time for us as data professionals, right? And so trying to identify like what is important and now being able to realize people are saying, oh, we want to actually really have a whole bunch of word embeddings or documents translated into those embeddings so that we can look and search for them. It's just like you said, like the usefulness of the data that we've had before has really it's been huge, right? So I think that's definitely driving a lot of this vector database hype, but also not necessarily hype actually interest, right? So
Yeah. So, when you think about the future of just databases in general, do you see them moving more towards like vector databases, traditional relational databases? Are we going to start adding in knowledge graphs? Like, where do you see the future of just databases in general?
and whenever people ask me this question, right, it's like the two things that I have to always think about is how much data are we working with, right? And how much data are um so we do overall have a lot of data. We have the production of data is humongous and it is so easy to create, right? And so being able a lot of times like the applicable like trying to pull information from that data that we already have, majority of the time it's smaller, like at smaller companies, right? That's still going to be coming from, a traditional database because they don't necessarily need the speed yet of a huge data of a vector database. When we're looking at larger companies, that's definitely because their latency, like the latency is really what matters there. And that's a big, a big component of vector databases is that they are very, very low latency, right? And able to search and find anything. So there are definitely use cases for, um, there's definitely the trend that I see is yes, fact days are certainly important, but for the smaller companies, or medium-sized companies, it's still going to be the traditional database that is going to be a huge focus.
So, you have worked so many different roles in the field of data. And that's one of the reasons why I love working in this space is because, once you get into what I'll call like the job family of data science, right? You could be a data project manager, an analyst, a data scientist, a data engineer, a machine learning engineer, etc. You've hit a majority of those roles everywhere from data science to data engineering to now ML platform engineering. But I think the one common thread behind all of these is there is a lot of data engineering in it. And whatever you're going to be working with, you're going to have to work with a data engineer, right? So as we've seen with the proliferation of AI even added into the data science space, it can do a lot of more of the analysis and the algorithms. We're not even building a lot of these models from scratch. We're taking them out of the box, adding onto them, fine tuning them. But what remains the same is we still have to build the pipelines of data. Like there's no magic tool yet that I've seen. Maybe people are working on it and building it, but data engineering to me seems like one of the most fundamental skills you can acquire in this space. And if you get a really strong data engineering background, you can go anywhere from there, right? It's like that's foundational. And then from anywhere you can go. So from your perspective, what are the key skills and competencies that you think are essential to be a successful data engineer?
Right. Yeah. So I, like you said, like I want to touch a little bit on this too. Like, my background is really interesting because there's So I want to talk about this a little bit before we go into answering the question. So I did I was a data consultant first. I had no idea. So um when I entered the field, I was a actually just graduated from my master's in computational chemistry and theoretical chemistry. And I had no idea what I was wanting to do, right? And that's how most people come into this field. It's like, I mean, they tell you, "Oh, this is data science. Data science is that, very, every time, hot, sexy, whatever, right? Job." And I was already working with data, right? I worked in chemistry, and so I was like, "This is just a natural trend for me." And I ended up deciding to go into consultancy. So I worked for like an actual company that was a consultancy because I didn't know what I wanted to do. And um, it is really interesting because when you go into the consultancy, and this is why I highly recommend for anybody who has no idea what they want to do, is to go in consulting because you see so many different projects. Like you go from data science, you go to data engineering, you go to like whatever is needed, right? You basically become that person, and so you quickly figure out, oh, I do not like dashboarding. Right, that was one of my biggest thing. Like sure, like, I can present data to you, right, in a way, but, like, sitting here and trying to figure out this is exactly how I want to present the information to the stakeholders or the clients, like, and then moving around. That wasn't necessarily what I wanted to do. Um, I quickly did realize that data engineering, like, that's also where my strengths lie. It was that, I was really interested in coding and things like that. So now to go back to to what are great skills for data engineering. So the biggest ones were obviously Python, right? So Python is really important, but Spark, understanding and handling Spark. So like with Spark comes PySpark. So um, for the engineers, usually to or Scala or PySpark. I usually recommend PySpark because it's much closer to um, uh, Python. And then like something like Docker is like starting to understand what virtualization is, and that's very important. So that's one of the biggest trends I see is like as we're growing in tools that we have, a lot of them are also asking for like we don't want to just spend a whole bunch of money to get a tool. We want it to be in house and get learning. So those are the two. When I started learning Spark, which was about 2 years into my about a year or so after that, like my job openings increased because everyone really wants to be able to handle a lot of data, right? And so those are definitely the three like technical skills that I see. For behavioral skills, it's usually your curiosity, right? Like and wanting to learn because your tools are going to change. Like, yes, we use Sparks, the framework, but even within Spark, like there's so many changes that are happening. Like, looking at 3.4 versus 3.3, there's, the addition of like offset and things like that. Oh, and also, of course, I forgot SQL. Duh, SQL. Um, and SQL is also a really big one. I I do most of my like aggregations and things like that with PySpark, but there's also a lot of a lot of positions that are very SQL heavy. And so one of the biggest ones is like optimizations. How can you get, like, you take a tool from, or you take a SQL from a data scientist or data analyst, and how can you optimize that so that the database will um, read it in and make you more efficient so that overall, right, the team is overall becoming a better taking care of databases. But yeah, so getting back to the behavioral, right, it is curiosity and like learning, right? So curiosity because everything, like, you need to be curious about the data that you're understanding, right? You need to be able to put yourself in those shoes to like, why would the user do this or that, or like what is the um how would we get that data to look a certain way, like things like that. So just naturally being curious about the data. And then the second one is ability to learn, which is, or just learning in general, because everything is changing. Python is changing, Spark is changing. What the next, like, vector database is, which is what we just talked about, right? Like, so it is such a dramatic, like that's one of the reasons why I got into this field is because I want to continue to learn and I want to continue to be challenged. And so those are definitely the two key behavioral competencies that I would look for if I were hiring. And I've done before.
Yeah, so if you're starting out, kind of tools are SQL, Python, PySpark, or languages, I should say, stick to those. And then from the behavioral side, curiosity and this hunger for continual learning is really key because, yes, not only, even if you know certain tool or languages, there's always enhancements to it and further you can go, let alone just new things coming into the industry, right? So if you're someone who loves learning and is curious, it's a great place to be. For someone starting out, you mentioned starting in consulting, which is great to get exposure to a lot of the family of data science jobs that are out there. But if somebody's like, hey, I know I want to be a data engineer, what's the best way to get started in that field?
Yeah, so my biggest advice, what got me into the field, right? What has gotten a lot of other people in the field is getting experience, right? Being able to showcase that you have projects that you've worked on, whether that is in your current job. So one of the things I did is I was an online tutor for a little bit, trying to in between my data consultancy and also post my graduation. And I took that data, created a dashboard for it, and then also predicted how many tutors we would need. So that's like the quickest way for me to showcase because I was already doing that on the job, right? Of course, my manager was like super supportive of this too, um, and I was able to say, "Hey, look, like I predicted up to one tutor, um, you know, correctly, right? So we only needed one more tutor, and we would have gotten like the correct number of tutors to meet the students' needs." So that's definitely what I highly recommend is getting that experience, making like finding. So if you don't have a job that allows you to do that, finding the time on the side, to find a unique data set. So unfortunately, Twitter isn't as much of a unique data set anymore, but combining that with other pieces of information that you can find, there's a whole load there. So census data every time that changes. So and there's always new different ways of looking at it. And so that's really what I highly recommend. Start learning from the basics, and move through the projects is also um, the best way to figure out like where you're also good at. So
So you recently made a shift from data engineering to ML engineering. Can you talk a little bit about your transition and what motivated you to make this shift?
yeah, so I as being a consultant, like I was mentioning, is like I got a lot of opportunities. So I was already working a lot with models when I was a consultant, and then I was already really there's a lot of need for data engineering, right? So there's a lot of data infrastructure and a lot of skills that are also applicable into the machine learning world. So machine learning is a lot of people just think it's we're working with models, right? But it's also making sure that you can figure out how to procure that data, right? So how can I get the data from the data pipelines? How can I get transition that through, right? Feature engineering is a huge one. How can I optimize the SQL queries that are already running? And those are all skills that you already have in data engineering. So it wasn't for me, it wasn't a huge jump because my experience was like I already had some modeling in my background and then data engineering just really strengthened that. But ML, I mean ML, as we all know, ML is growing rapidly, and there's also a lot more positions. And so I was trying to find a new way to challenge myself. As I'd also been in data engineering for a little bit, so like all of my past experiences have added up to be for me being a great MLE. Um, so that kind of the one of the biggest transitions. So when I got it, I took it right. And yeah.
Yeah, I like what you mentioned, all of your experience that have led up to this, and everything in the data family of jobs kind of builds on each other. Would you say there's like a best path to get started and like you should start out as an analyst and move to a data scientist and then a data engineer. And then after a data engineer, an ML engineer, like, or does none of that matter, right? You can pick whichever one and then expand and add on to it from there.
To be honest, it doesn't really like it doesn't matter. There's no one correct path. I mean, that's really the coolest thing about data world is that there's literally no correct path for you to go. I've seen some going from I think the biggest jump though is going to be between data analysts and the two engineers and science. So that is one of the things that I think data engineering is actually probably one of the easier ones to get into, not because of it being an easy field. It's just that the skills that you need are a lot very coding heavy, and coding skills are tend to be easier to acquire. And then switching over to finding a data science position within your company, for example. And so they're all equally challenging, right? They all have their own areas that you can focus on and you're strengthening on, and it also really depends on what you enjoy. Like if you don't like coding, then obviously don't go to data engineering or machine learning engineering, right? Data science has some less coding, and so that would be one of the directions I need to go. Hey, have you considered data analyst or data scientist, right? Um, and there are a whole bunch of like competencies that are different between those. So mine is really like I really like to figure out systems and building upon those, and so that's where like data engineering and data and MLE has been a huge passion of mine.
So for data engineering, you mentioned, knowing Python, PySpark, SQL are key. What have you seen shift now that you're in ML, platform engineer? What additional skills did you need to add on to that, or do they remain this?
The tools that we're currently using are actually pretty similar. Um, my biggest skill that I've needed to like figure out is definitely like more to data science. So like what looking at modeling, right? Looking at statistics. Data engineering doesn't require like the most of the time it's pretty basic statistics. It's like, paying to the mean, standard deviation, things like that. But data science is trying to go back into like, okay, so what kind of model is this? Can we use this actually to solve the problems that were asked being solved? And things like that. And so that's usually that's where my currently the biggest learning curve has been is like going back into that. Um, but yeah, so other than that, I mean, my data engineering skills are being used. I'm still using PySpark. Spark is just it's a phenomenal tool. I will, if you listen or like if you read any of my posts on LinkedIn, like I'm a huge Spark fan. And it makes a lot of the data. I've seen the power of it not being used and then power of being used, and it just makes a huge difference. And then also like learning about like, like what is online inferencing. So one of the tools that I've now been using is ML Flow, which is not something that engineers typically use. Highly recommend ML Flow if you need a model registry, right? Or if you need to figure out what like metrics and things like that. So it's definitely like the model world where I've like gotten the most growth in the last couple.
So a lot of times in this episode, you've talked about how important continual learning is in this space, and you've talked about the new things you're learning and continuing to learn. How do you stay up to date on all of these things? I mean, it can be so overwhelming. You even mentioned like, yeah, this last week we heard that Python and Excel are integrated, and it's like, particularly right now, there's just so much happening in the industry. How do you stay up to date and also know where to focus your time?
So the majority of my time actually spend reading LinkedIn, right? There's a lot of great follow people to follow. Have read Sahuta, which does a lot of ML things. Zach Wilson and oh my gosh, Sinram, like she's Netflix data engineering Netflix. And so there's a whole bunch of like creators who are out there like giving content that are excellent. So finding those out. And I usually share those two on a regular basis. So you can if you look at my posts, I'll share them. So there's folks that you can look at. And then there's also like, so when you look at companies like Netflix, they have their own blogs on Medium. So that's also huge. And especially trying to figure out like, So a lot of times what I do right now is looking at platforms, right, and thinking about, okay, what tools are we trying to integrate, and what's been effective and what has not been effective, right? And so Medium has been a huge start. So I look a lot of both like Netflix, their own like engineering side, but also the Medium portion. Um, Data engineering things is also a huge one. And even like towards data science, right? So a lot of times that they'll have really great curated content. I've been looking a little less at Medium though, because I just have gone overwhelmed as I create content too, right? And so trying to manage those both times. Yeah, so this has been my, but like we mentioned, like we've talked before, like it's really hard to get a lot of data engineering focused content and even some ML engineering. So what I mean specifically about it's not like the specific algorithms, but more about like how do I build those platforms out and things like that. And so that's one of the reasons why I started writing too. I mean, it's it's what I, like having that face ready, but also like, looking at the information and looking at, okay, so what does a correct like platform actually look like and things like that. So that's been my main focus on like where I get my content from. And obviously like we just talked about, like the learnings that I take from work. I have a great manager who is very well aware of what's going on too. And so being able to use him as a resource has been phenomenal as well. And also like, the entire team. The entire team, obviously. But yeah.
Well, as we wrap up today, what's one piece of advice you have for women in data? I mean, being a woman in data yourself, if you could give one piece of advice, what would that be?
Really like try to find your passion and then try to find other people who have that same passion. Right. So I have been the I've been one of the only females for in engineering in general for like the majority of the other um for most of my career. And it sucks. It does. And but I've been also now finding people outside of my company, like especially as I started being more um like posting more on LinkedIn and X and at threads too. Like, you start to find people like yourself, right? And others as well who have that same passion as you do for data and who are really like have a passion also for engineering, right? And so being able to find those, so being like really finding that group of group of people, I think is really important. Finding that support system, right? And it makes it all like I love working in engineering systems. And um I have had my hiccups too, but it makes it worth it when you find those other folks who are also there and have also worked with the systems and are supporting you through it too. So, and then of course, like I love because now I'm at that point in my career where I can start mentoring other folks too. And so seeing those younger folks and helping them through the challenges that they are facing. That's probably have been my biggest like impact in the last couple of months, even like just seeing them grow in their career. That's definitely been my highlight. So that's how that would be my biggest piece of advice.
Well, Sarah, thank you so much for taking the time to come and chat with us today. This has been really insightful. If others want to continue to learn from you and be mentored through the wonderful online platforms that we have today, what's the best way for them to connect with you?
Yeah, reach out to me on LinkedIn and think that this link will be below, right? And also I write a newsletter called dutchengineer.substack.com, and I write about data and ML related things and also career. Yeah, that's and I do that every week. And I write on LinkedIn most of the days. So that's the best way to reach me. Yep.
Well, thank you again. And a big thank you to our listeners. Remember to stay curious and keep learning. And we'll catch you next time on the Data Bites podcast. Bye bye, everyone. Thanks so much for tuning in to another episode of the Data Bites podcast. If you're looking for more resources to further your data career or find your tribe, we encourage you to become a member at womenindata.org. See you on the other side.